In section 8.3, we're going to look at dot products. Here we start out with the magnitude of BA is equal to the square root of A minus B squared plus A2 minus B2 squared. So in other words, the magnitude of the hypotenuse is equal to the magnitude of B squared plus the magnitude of A squared. So let's do this. Let's square both sides. We have BA, magnitude of vector BA squared, is equal to A1 minus B1 squared plus A2 minus B2 squared. And that's equal to A1 squared minus 2A1B1 and then plus B1 squared. Then when we FOIL this one out, we get A2 squared minus 2A2B2 and then plus B2 squared. If we rearrange a little bit, we get A1 squared plus A2 squared, and then we get plus B1 squared plus B2 squared. So that takes care of this one and this one. It also takes care of these two. And then we can factor out a negative 2 and get A1 B1 and then plus A2 B2. And let's bring this down, the magnitude of BA squared. Well, now we have the magnitude of BA squared is equal to, so let's see, magnitude of BA squared is equal to, the magnitude of A is actually square rooted, but we don't have that square root. And to get rid of the square root, we would square. So this is actually equivalent to the magnitude of A squared, and then by the same token, this is equal to the magnitude of B squared. And then we have minus 2 times A1 B1 plus A2 B2. Now this is only a true statement if this piece right here, if A1 B1 plus A2 B2 is equal to 0. Because then if this is equal to 0, we have the Pythagorean theorem right there. This piece right here, A1 B1 8 plus A2 B2, is called the dot product. Key concept: dot product of vectors at a plane. The dot product of A and B is defined as, we have A dot B is equal to A1 times B1 plus A2 times B2. Orthogonal vectors. The vectors A and B are orthogonal if and only if A dot B is equal to 0. And orthogonal means perpendicular or 90 degrees. Find the dot product to determine orthogonal vectors. Find the dot product of U and V if U and V equal these. Then determine if U and V are orthogonal. So U dot V is equal to, we have negative 3 times 3, that's negative 9, and then plus 4 times 6 is 24. So that's equal to 15. Determine if U and V are orthogonal? No. Find the dot product of U and V if U equals 2, 7 and V equals negative 14, 4. Then determine if U and V are orthogonal. So U dot V is equal to, we have 2 times negative 14 is negative 28, and 7 times 4 is a positive 28. That's equal to 0. So the dot product value is 0. Are they orthogonal, or in other words perpendicular to each other? The answer is yes. Properties of the dot product. If U, V, and W are vectors and K is a scalar, then the following properties hold. We have the commutative property. U times V equals V dot U, actually dot. Distributive property. U dot V plus W equals U dot V plus U dot W. Scalar multiplication. K times U dot V is equal to K times U dot V, or U times KV. Zero vector dot product property. 0 times U is equal to 0. Dot product and vector magnitude relationship. U dot U is the same as the magnitude of U squared. Show that U dot U equals the magnitude of U squared. Let's let U equal to U1 comma U2. And then if we have U dot U, that's equal to U1 comma U2 dot with U1 comma U2. And so the dot product is equal to u1 squared and then plus u2 squared. And the magnitude would be this thing square rooted. So this is equivalent to the magnitude of u squared. Use the dot product to find magnitude. Use the dot product to find the magnitude of a, which is negative 6.5. And since the magnitude of a squared equals a dot a, then the magnitude of a is the square root of a dot a. So we have negative 6.5, negative 6.5. If we do the dot product, we get 36 plus 25, and then to find the magnitude, we square root, which is the square root of 61. Use the dot product to find the magnitude of this one. So to find the magnitude of v, we have negative 4, negative 1, and we have the dot product with negative 4, negative 1. So we have 16 plus 1, but then the square root of that. And the square root of that is 17. Angle between two vectors. If theta is the angle between non-zero vectors a and b, then the cosine of theta is equal to a times b, or a dot b, over the magnitude of a times the magnitude of b. Find the angle theta between u and v to the nearest tenth of a degree. So we have the cosine of theta is equal to a dot b, which will be negative 6 plus 15, and then divided by, we have the magnitude of u, which is the square root of, see, 9 plus 25 is 34, and then 4 plus 9 is 13, so times square root of 13. So the cosine of theta is equal to, let's get the calculator, we have negative 6 plus 15, that's 9, then we're going to divide by square root of 34, and then we can divide by square root of 13. We have a value that is less than 1, so now we can take the inverse cosine of the answer, and I'm going to make sure we're in degrees. We are. And so the answer is, these two vectors make an angle. Theta is equal to 64.654 degrees. Here we have a diagram. Here is the first vector in standard position, negative 3, negative 5, and 2, negative 3, and here we have an angle of 64.7 degrees. Find the angle theta between u and v to the nearest tenth of a degree. The cosine of theta is equal to, we have the dot product between u and v, which is 2 minus 24, and that's over. The magnitude of u is the square root of, let's see, 1 plus 16 is 17, and then times the square root of 4 plus 36 is 40. We have 2 minus 24, that's negative 22, then divided by the square root of 17, and then divided by, we can just do square root of 40. So that's equal to, so cosine of theta is equal to negative 0.844, and then we want the inverse cosine of the answer. And that's equal to 147 degrees. So 147.529 degrees. Let's take a look at the diagram of it. There's the angle between the two vectors, and it's 147.5 degrees.